the 10 million pleasure craft in the US, they emit more non-CO2 emissions than the 286 million registered passenger cars in the US.
This is because of the NOx emissions that they're not required to fit catalytic converters, right? So
exactly, the NOx, the SOx. It's a mind-boggling number. Me personally, that's one of the things that I've noticed the most, and is the hardest part about going back to a gas boat. It's just the constant inhalation of fumes.
Hello, I'm Bryony Worthington, and this is Cleaning Up. This week, we're delving into the topic of electric boats. Not the giant ocean-faring vessels we discussed with Johanna Christensen in episode 143, but the tens of millions of small boats of between 10 and 50 feet in length, boats that are used commercially and recreationally for everything from fishing to towing wakeboarders. While the traditional marine engine manufacturers are busy competing with each other to produce ever bigger engines, a small group of companies are innovating from the ground up with electric alternatives. These need to work reliably and affordably in the relatively challenging conditions that accompany life on water. So the race is on to see who can become the Tesla of the waves, providing a product that offers higher performance, lower fuel and maintenance costs, and pollution and noise-free experiences, and also importantly, cracking how to scale a business. While there are thousands of boat manufacturers, the combustion engines that drive many of them are fairly centralized and dominated by a handful of large global players. From Japan, Yamaha, Honda, Suzuki, and in the US, Mercury. All have their own electric alternatives available now or under development, but the question is whether, like in the car market, the pace of change will be increased by competition from new entrants. And there are a range of new companies innovating in this space. In Europe, perhaps the best known is German company Torqeedo, founded in 2004. They've sold 250,000 electric motors to date, and this year were acquired by Yamaha Motors. Norwegian company Evoy have recently joined forces with Vita, a UK-Monaco-based company, and Candela, another Scandinavian boat builder, are revolutionising engines and boats with their hydrofoiling concept. In the US, one of the largest markets for recreational boats, change is also on its way. Founded in LA in 2021 by former SpaceX engineers, ARC is a company developing high-performance luxury boats. While on the East Coast, Flux Marine, headquartered in Newport, Rhode Island, have also entered the market with their customizable electric propulsion offerings. And today, to explore this topic in more detail, I'm delighted to be joined by Ben Sorkin, Flux Marine's co-founder and CEO. So please join me in welcoming Ben to Cleaning Up. So Ben, thank you so much for joining us here on Cleaning Up. We're going to kick off, as we always do, with the first question, which is, could you introduce yourself in your own words and tell us what you do?
Sure, absolutely. It's a pleasure to be on here. So my name is Ben Sorkin, one of the founders here at Flux Marine, CEO, and who I am is I'm a passionate boater and a tinker at heart. Grew up boating my whole life, so that led me to kind of where I am today, running Flux Marine. And here at the company, it's still a startup, so everybody does everything. So I spend my time talking to investors, cleaning up bathrooms, and leading technical developments.
And we should note for our listeners that you are actually in the manufacturing plant today, and so there might be some background noise. We're going to hopefully keep it to a minimum, but that you're in a place where you're building boats today, right?
We're in our 40,000 square foot facility, so motors are cranking off the lines, systems are getting tested, so it's about as authentic as it gets.
Brilliant. And Ben, I'm really looking forward to this conversation because I was fortunate enough to meet you in New York and to actually go on one of your craft out on the water, which was a really great experience. But that sort of got me really interested in this question of electrification of boats and ships. And we've done previous episodes looking at the big picture, all of the big vessels, but we've not looked at smaller craft. So I thought it was a great opportunity to explore that with you. But we should begin perhaps could you tell us the story of how Flux Marine came? How did you come to be setting up a new company in this space?
Yeah, that's a great question. And, even taking a 30,000 foot view of what exactly is Flux Marine, we're a technology company that's producing electric propulsion systems for boats, mainly boats between 10 feet and say 40 or 50 feet. We're not a boat manufacturer per se, because there are thousands of companies out there that build boats. We're a propulsion company, so we can actually partner with those thousands of companies that build boats. And in terms of, how we got to where we are today, it's really a story of passion, I would say. So again, growing up, after spending every summer in upstate New York on Lake George, I was rebuilding old boats, tinkering with boats, fixing boats. But always, it was a little bit of a double-edged sword where I also knew that pleasure craft and small craft are really not the best for the environment. I mean, outboard engines still don't have catalytic converters, which were required on cars over 50 years ago. So there's a disproportionate volume of pollution that comes from boats. And so by the time I was in college studying mechanical and aerospace engineering, really started thinking about how come nobody's really pushing the frontier of marine electrification. There were clearly trolling motors, think about under 10 horsepower, dozens of companies doing this, hundreds of thousands of motors out there for very, very small stuff.
And you've used a word there that's perhaps not familiar for our listeners. So trolling, I sort of associate that with things that go online in chat groups, but you mean that specifically for a type of boat, right?
Yeah, a type of way you use a boat. So a trolling motor is basically a motor, a very small motor. It's usually a secondary motor that goes on a boat, usually electric, and it's used for going very slow. So kind of trolling around slowly. Main application there is kind of fishing. You think about you're on a 22-foot boat with a big gas engine, you go super fast to where you want to be, and then you're sitting there fishing, moving very slowly, just using your trolling motor.
Okay, great. I've learned a new word. Thank you.
It's a good one. And so there were a lot of companies doing that, but there were very few companies who were really trying to tackle the problem of, the larger market, the 50 plus horsepower market, who's building electric propulsion systems for those boats. And the answer was no one is really doing it in an innovative way. And this was back in 2015. We started thinking about this. And so from 2015 to 2020, those 5 years were categorized really about thinking what is the best overall approach to electrifying the marine industry. And those 5 years were spent finishing up university, working in labs, skipping class, doing projects, working at other companies. I worked at Tesla for a bit. I worked at a defense engineering firm, and worked at all these places with the lens of what can I do to help further the mission of coming up with the right mass scalable approach for electrification. And, at the conclusion of those 5 years and prototypes, building at night, going to pitch competitions, getting small grants, we had this pretty much this well thought out plan about we need to start from a clean slate of paper. We need to design an outboard motor, which is the most common type of motor sold today for boats. It can't be based on a combustion system. It needs to take efficiency into account. It needs to eliminate a lot of the maintenance and pain points of existing gas engines. It needs to be lighter than what's out there, and it really needs to perform. And so numerous concepts were developed over time, over these 5 years, tested on a lab scale, individual, early rudimentary prototype scale. And then in 2020, we went out and we raised a small round of capital. And that allowed us to kind of take this 5 years of research and planning and actually start developing. So from 2020 to 2022, we built up a team of about 12 people, those really great superstars who wanted to, join something brand new in a small garage in East Greenwich, Rhode Island. And we built a couple full-scale prototypes that incorporated all of the ground-up innovations. And when I say ground-up innovations, a few of those are, for example, a closed-loop cooling system. So whereas typical gas engines actually suck seawater in, circulate it through for coolant, and spit it back out, seawater has salt in it, and that induces this lovely thing called corrosion and induces more maintenance. So we said, let's avoid that. So our closed loop cooling system effectively eliminates the ingestion of any seawater. So that was a huge improvement. 2, spent a lot of time on motor, batteries, and power electronics. If you think about the use case of a boat, it's much more demanding than a car. If you jump in a Rivian, you've got 835 horsepower for acceleration, but on the highway, you only use 30 or 40 horsepower. So the motors and batteries and power electronics from a car are designed for exactly that. High peak power, below continuous power. Shift to a boat. How is a boat used? A boat is going through water, which is 800 times denser than air. So instead of that burst of peak power and then low continuous power, the faster you go, pretty much the more power you need. So if you were to take automotive components and drop them in a boat, you would run into thermal issues and overheating issues very quickly. So we developed a powertrain that was well suited for those high continuous requirements. Then you think about power transmission. Typical gas engines use a belt drive or a bevel gear system, mechanical shifting bevel gears. You lose anywhere from 10 to 30% of the energy in that. We've developed a belt drive, a synchronous belt drive that actually is about 97% efficient. So it was all of these concepts that we put together in the first set of outboards from 2020 to 2022. Prove those out, use those to raise a bit more money. We then raised our Series A, and that's when we got involved with Chris Anderson, Stephen Petronic, and Ocean Zero. They led our Series A round, and that allowed us to take these fully built working prototypes and move them a step closer to commercialization. Actually develop them into a product, make them rugged, robust, and actually put them in the hands of customers. And over the last 2 years, we've had dozens of those systems out in the field with customers, getting feedback, iterating, which is an important part of any, hardware startup. And we're now at the point where we've taken those thousands of hours and, dozens and dozens of systems, all that feedback, iterated, and we're now in pilot production or early production of motors that are going to customers, and we may never see those motors again. So we just sent one off today to the British Virgin Islands. So we're now in production.
And you say that confidently because I guess one of the things that you've figured out was that maintenance of boats is like a horrible aspect of boat ownership, right? There's a lot of moving parts in a traditional outboard motor and a lot of corrosion, as you said. And so are you confident that you can send a battery alternative, your alternative, out and hopefully never hear from a customer again? Is that realistic?
I think it should be realistic. We did enough testing over the last 2 years with customers and, identified every single potential issue, analysis, root cause. And we've had boats in the field now since production where, the only thing you hear from the customer is, hey, thanks for a great season. So, because we've spent so much time developing the technology, doing so much in-house ground up, we feel super confident about the longevity of these systems. And while we're testing for years and years out in the field, we've also simulated decades of testing internally through our dynamometers and test rigs in our building.
We should probably pause because that was a fantastic detailed description. But going back a step, the promise of electric in a marine environment is there's lots of advantages, right? So firstly, they're silent. And for the recreational boat market, I would have thought eliminating that really loud engine noise at the back that prevents you from actually having a conversation with anyone, that's presumably a big selling point. But there are lots of other features about electric that really seem to give you a better product, right?
Absolutely. And that's really what we set out, is to build the best boating experience, and made it our job to make sure it's a sustainable experience. So boating is so unique. There are hundreds of different boat types, thousands of different boat combinations, and tens of thousands of ways to use boats. And so each application is unique, and each application values different parts of the experience. So without a doubt, sound has been a very big part of what we're doing. And the number of comments I get, even today, we sea trialed one of our boats with the new owner, and they were like, I can't believe we're having a conversation right now. So people love that. The fumes are also a really big difference. So I think, me personally, that's one of the things that I've noticed the most and is the hardest part about going back to a gas boat, is just the constant inhalation of fumes. And especially if you're going slowly, 3 or 4 miles an hour with, 5 or 6 friends on board, want to do a harbor cruise. It's so nice with the electric because you just smell the air, the salt air, instead of inhaling those fumes. And those fumes, it's not just like car exhaust. The amount of carbon monoxide, NOx, SOx, PM2.5, there's 150 times as much of that stuff per gallon burned compared to a car. So it's like inhaling the exhaust of 50 cars or 150 cars right in front of you. So a huge difference there. And then the other, I think, really interesting convenience factor that we've seen with the electric is not having to go to the gas dock to refuel. In the marine world, it's gas stocks are not as abundant as they are in the automotive world and in the streets. So oftentimes fueling up is a hassle. Either you're lugging a gas can down to your boat or you're waiting in line to fill up the boat on a nice day when you'd rather be out on the water. Most of our customers, where they keep the boats, they have power outlets right there. So they leave it plugged in overnight and they start every day with a full charge. And it's just so much more convenient.
Well, I can relate to that. And I think that's one interesting factor that is very different to to doing this transition on land is that marinas nearly always now have shore power for people to plug in for their ancillary services, right? Because they may be running a fridge or electronics. So you've already got kind of a trickle feed electronic system in place in marinas. So you're not having to wait for that charging infrastructure. But I guess fast charging might be something you need to add over time.
Yeah, exactly that. And I think what was cool, and you came down and we jumped on the boat out in North Cove, right in Manhattan. Right where the boat was, we're next to a larger boat that was plugged into one of these outlets. And we looked around and we saw outlets at every single dock. And so the infrastructure really already exists. And for the majority of use cases, if you start every day with a full charge on one of these boats, it's more than enough range for what you need to do. So a lot of times we see that people never even need fast chargers. That being said, I think fast charging is a great addition, and we'll start to see more and more fast chargers at destinations. So think about something like Block Island, which is, could be 20 miles away from wherever you're starting, which is, could be 2 or 3 hours of a trip or faster. Having chargers there would be super helpful because then you can go out there, go for lunch, go for dinner, top off, and rip back. So
Yeah.
all of our systems are fast charge capable, and we're looking forward to seeing more of that infrastructure out there.
Yeah. And something we touched on when we were on the trip was the fact that a car, I mean, Elon Musk just announced his robo-taxis and used this interesting statistic where, the average car globally is only used for 10 hours out of 168 possible hours. And I imagine that the stats for boats is even less, right? So
Absolutely.
recreational users, I imagine, think they're going to use the boat a lot more than they are. And all boats spend a huge chunk of time at the marina. So does that open up opportunities for flexible grid management and vehicle to even, boat to grid potentially?
It certainly does. It certainly does. And one of the exciting things about developing so much of our technology in-house is we have full control over how we can use our batteries, our own battery management systems. Everything's connected via IoT, so we're able to see all of the data. And what that means is when it comes to, okay, now using a boat as a battery bank, we already have everything on our side ready to go for something like that. So we're definitely in conversations with groups right now, and it's something we're certainly working on. I can't say too much about when we'll unveil it per se, but without a doubt, we're looking at this, we're not a boat company. We're not even just a propulsion company, but we're truly, a technology company that is ready to apply our battery tech, our motor tech, our inverter tech, our thermal management tech across the board. And, I think I'm a big believer in the energy transition overall. It requires end use to be sustainable. It requires original generation to be sustainable. But then there's also innovation needed on distribution, temporary storage, and load leveling. And so we certainly plan to be a pretty big part of actually how energy gets distributed, used, and stored.
And for a boat owner who's burning cash just by having the pleasure of a boat that they may use, at least this would be a guaranteed source of income if the whole marina is contributing to grid balancing, which might be quite nice.
Exactly. And, I wouldn't be surprised if, next time you visit Rhode Island and if you come over to where I live for a cup of tea, you might see a boat in my backyard plugged into the house, and the house cannot be charging the boat.
That's really nice. Well, I might take you up on that offer. But listen, before we get too carried away, there are some things that people will be thinking about, right? So, for example, range anxiety. If you drive an electric car, the worst case scenario is you're going to have to limp up to someone's house and beg for an extension cable and rescue yourself that way. When you're out at sea, I mean, the risk of not having charge or the battery not working is far greater. So how have you approached that? And I mean, how much of an issue is that anxiety?
So I think it comes down to education on the consumer side, and then energy management on our side, the Flux Marine side. I have yet to run into an encounter where I run out of charge on one of our boats. And I'm embarrassed to say how many times I've run out of gas in the last 10 years on boats. I think with the electric boats, you always have a very, very good understanding of exactly how much energy is left. Whereas on a gas boat, you've got the fuel indicator and, it's pretty accurate. But it's always, it gets to the end there, how much do you really have left? Are you close? You're not that close. So with the battery powered boats, you're able to see that exact percentage, that exact state of charge. And in turn, you're able to see the range and how far you can go. And what brings us back to, I think, the dynamics of a boat. And when we talk about when a boat's going fast, it needs a lot of power all the time. But when a boat's going very slowly, it becomes hyper efficient. So think about moving a boat very, very slowly. You could take a 5,000-pound boat and you could sit on a dock and you could sit there and you could push the boat away and it'll go move a little bit. If you got behind a 5,000-pound SUV on flat ground, I don't think you'd sit there and you could push it. It's a lot harder to get going. So kind of pulling that all the way back, if you look at how much energy or how much power you need to move a 5,000-pound boat at 3 miles an hour, you're talking about the amount of energy as like an incandescent light bulb, like a couple hundred watts. It's incredibly low amount of power. So you could basically go full speed in one direction and drain 90% of your battery pack. And then realize you have 10% left, and our software helps you not keep going full speed at 10%, but it starts to limit the amount of power you can have. And then on 10%, you could make it slowly all the way back to where you started.
When you said at the start, which is absolutely right, that pushing something through water, which is many times more dense than air, takes more energy. I was actually recalling the things that I'd learned when I worked on shipping, that overall, actually moving things on water is very efficient because the friction is less, right? So you can take these huge, very, very large ships, massive displacement, but they glide through the water with relatively low energy because of the lubrication, right? So what you're saying is you can capitalize on that to then make sure you've got an energy efficient way home.
Exactly.
Talking of energy efficiency, there's quite a lot of news stories in Europe at the moment about Candela, their hydrofoiling boat has just crossed the Baltic Ocean and on electric power. And by lifting the boat out of the water, obviously, then you've got a certain efficiency gain. I mean, what did you look at hydrofoiling and what made you keep your boat on the water?
Yeah, definitely looked at hydrofoiling, and I know the folks over at Candela well, and have utmost respect for Gustav and everything he's created. And if you want to look at it in straight apples to apples efficiency, a hydrofoiling boat is more efficient. That being said, hydrofoiling craft does not have the same versatility as a standard boat. And at the same time, Flux Marine's goal is to enable as much impact as possible and in as short as possible amount of time. And that's why we wanted to develop something that could be used with the thousands of boat manufacturers and hundreds of thousands of boats that already exist. And so if you go to, say, Scout, for example, Scout's one of our boat partners. They make a great boat. They make over 1,000 boats a year. And you wanted to electrify that with hydrofoils, you can't just take a Scout off the line and put hydrofoils on it. The amount of work that Candela and Gustav did to make, a fantastic foiling boat is not insignificant. You can't just do that to every boat. That being said, we developed a modular enough battery pack, a lightweight enough and efficient enough propulsion system where Scout really doesn't need to change much. They can just send a boat off their regular manufacturing line, put an electric propulsion system from Flux Marine on it, and then send it to a customer. And so our systems are certainly geared more towards the mass market, and then, can be used in applications that are more versatile than something like a foiling recreational boat.
And just thinking about that a bit further, one of the reasons you're able to partner with all of these thousands of boat manufacturers is that your battery packs are, am I right, that they're configurable in different shapes, right? They're not, you haven't just decided on one to presume that opens up a lot of potential partnerships.
Exactly. We have modular building blocks that can be oriented in different ways, combined in different ways, different numbers of modules, so different total energies. And that allows us to outfit a 22-foot Scout or go to a 22-foot Highfield, which have very different deck layouts and still put the same number of battery packs in them.
Just staying with the batteries then for a second, these are lithium-ion batteries. Have you had to do anything novel to them for the marine environment for this application?
Yeah. So as far as the battery pack goes, it's a mixture of making sure working with the right cell chemistry for the marine continuous use case, and then making sure the pack is marinized. And so we develop our own battery packs in-house, our own battery management system. So making sure we're looking at things like isolation monitoring, careful temperature monitoring, careful voltage monitoring, and then really ensuring that our pack is totally waterproof. So we're not designing our pack to be weatherproof or splash proof. We're designing it to be practically submersible. And we have engineers who have built underwater vehicles in the past that are building the battery packs. So we really designed a battery pack to handle significant loads, significant G-forces. Think about people jumping over waves. As we did out in Half Moon Bay, we were jumping off 15-foot rollers in the Pacific.
I'm sorry I missed that one.
It was a fun one. It was a different experience than we did on the Hudson. But building the packs for kind of those high loads and making sure they're truly waterproof is something we spent a lot of time and effort on. And then making sure that it's connections, the internal pack connections, the cell-to-cell connections, the module-to-module connections, making sure those are super rugged is critical in having a very safe pack for the marine environment.
And I presume you're benefiting as well a little bit from JB Streubel's innovations at Tesla, right? Where they took the standard lithium ion and worked out how to stop it from overheating through, the layering system. So I guess your company is enabled by the innovators who've come before, and Tesla being probably the main one.
Absolutely. And a lot of it comes down to, economies of scale. And if it were for companies like Tesla making literally millions of vehicles, battery prices would still be through the roof and the boats that we're selling would be 3 times as expensive as they are. But instead, we're able to leverage those kind of proven manufacturing methods and those economies of scale. And all of a sudden, to get an electric version of a Highfield is within 15% of the cost of the gas version. So, those groups who were really early, really pushed the boundary and really created, a scalable supply chain and industry most certainly helped pave the way for companies like ours to be able to kind of take what they did and, put the right twist on it and expand it to adjacent industries.
Talk to me about costs, because one of the things that holds back, I think, a lot of this is that these can be very expensive capital outlays for people compared to a cheaper alternative. So can you compete on cost?
Absolutely. And the reason that we can compete on cost is because of the time and the investment that we've put into everything, where we brought so much in-house, so much vertical integration, the costs have really come down significantly. And when you look at something like a 22-foot Scout center console or 22-foot Scout bow rider with the Flux system on it, it's around $120,000. If you look at the gas version with the similar specs, you're looking at a boat that's around $105,000 to $110,000. So that's, quite frankly, not a significant increase to the gas version. And then you start thinking about maintenance and operational costs, where of course it depends on how often you use your boat. But if you run a rental fleet and you have a P&L and you're tracking these costs, you can see a payback as quickly as 3 years, where it's more affordable to have the electric. And you're looking at the individual owner, the one thing that I think is more valuable than money is time. And so the amount of time and headache that you save with one of these quickly justifies that additional expense.
So basically you're saying total cost of ownership, very compelling argument. You know, no winterization costs, very low maintenance, and the fuel costs of obviously, you know, changing to electric. But the capital costs you're saying, I mean, these are not everyday, you know, costs. Not everyone can afford 120K for a recreational vehicle, but like for like, they're comparable. And over time, do you expect that to come down the cost curve?
Yeah, I'd say cost curve definitely comes down over time. But the other way to look at it is from a financing perspective. So a lot of people who buy boats finance them. So when you're financing a boat, now you're really thinking about what am I spending monthly on this? And the financing payment for a $120,000 electric Scout is honestly less than the financing payment for a gas Scout plus the gas that you're using, the maintenance, and the winterization. So, from a financing perspective, it actually makes an abundance of sense.
But do you think the people offering the finance are going to be worried by battery degradation? Like, how long does the warranty last? Like, are these things too new? They're going to keep breaking down. They're going to have loads of product recalls. Like, does the finance industry understand, or are these issues? Like, is battery degradation an issue?
So, the finance industry is worried about it and asking about it. And we've gone through some serious due diligence with some lenders. And, at the end of the due diligence, the result was, yes, we want to finance your systems. We were able to give them a peek into the technology, show how, from an IoT perspective, we can actually observe battery degradation, how we look at how much a boat gets used in a certain use case and how that affects the degradation, and show that the residual value is, virtually unaffected by standard use. And so after going through all that, looking at the data, looking at the simulation, looking at the results, the financing groups have seemed to really, really be a fan of it. And also in looking at the fundamental design, the no maintenance, the closed loop cooling, a lot of the financing groups that do financing for boating, think about groups like Ocean Point Lending from Bank Newport, they're used to financing boats and they know all the things that go wrong with the normal engines and the maintenance hassles. So when they see something like this, they get actually really excited about it. And so I think financing is going to be a very big part of the future of electric boating.
Cleaning Up is brought to you by the members of our new leadership circle. So that is Actis, Ecopragma Capital, EDP Portugal, Euroelectric, Gilardini Foundation, KKR, National Grid, Octopus Energy, Quadrature Climate Foundation, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform and leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues, and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com.
And let's talk about this industry then in terms of its scale. I think we've been, electrifying large-scale ferries in Europe for a while now. Norway certainly using its clean power. It's made complete sense for them to do that. And but how big is this recreational small boat market? And is the US probably one of the biggest markets, I imagine?
Yeah, I'd say the US is probably one of the biggest markets. But overall, it's, there are nearly 1 million outboards sold every year. And that's a pretty significant number. We're talking about market value, in the tens of billions at least. And there's a lot of money that gets spent on the maintenance and refueling of these things. So if you think about the total dollars going in to the, I call it small craft marine industry, it's north of $50 billion. So it's without a doubt a large market. And then from an environmental impact, it's totally outsized. Thinking about the CO2 and then thinking about the non-CO2 pollutants, which are also, greenhouse gases and oftentimes are more potent than CO2 itself, the 10 million pleasure craft in the US, they emit, I believe it's more non-CO2 emissions than the 286 million registered passenger cars in the US.
This is because of the NOx emissions that they're not required to fit catalytic converters, right? So
exactly, the NOx, the SOx. It's a mind-boggling number, and again,
But staying with the segment then.
Yes.
My understanding of this market is it's dominated by maybe 4 or 5 big outboard manufacturers, right? I mean, there's the Hondas, the Suzukis, the Yamahas. Then you've got Berkshire's Mercury outboards in the US. I mean, these are all very established, huge players with global distribution networks. How is Flux Marine going to fare in that very highly concentrated, very mature market? How are you going to break through?
It really comes down to focus and then the amount of time and investment that we've already done. So if we were sitting here saying, I have an idea for an electric propulsion system and it's me and my friend and we're going to get started now, it'd be extremely challenging. But the fact is, the original research for this started close to a decade ago. And by really vetting out all the concepts, there's some manufacturing going on in the background, but by really vetting out all the concepts early on and coming up with that right approach and staying focused on electrification, more manufacturing, by really staying focused on electrification, these big companies, they're not just focused on electrification. They're competing with each other on who has the next highest horsepower engine. And they don't want to lose market share on, their most profitable things. So it really gives us an opportunity to gap to prove that the market's there. We also have something that, to be honest, I don't think a few years ago, a lot of these larger companies thought it was possible. You get on one of our boats and we've had folks from other companies say like this, I didn't realize this was possible.
And that's because it's specifically the 100 horsepower range, right? Because the smaller stuff has been done, up to the 5 to 10 horsepower. That's kind of common knowledge, but it's this shift up into these sort of small fast crafts, right?
Exactly. And people did not realize that, we were this close to having something. And by spending, we've raised well over $20 million and really invested all that into the technology and built so much technology in-house where it would take years to build what we've had, between finding the right team members, the right expertise, getting years of feedback with customers. We're now at a place where I truly believe we're years and years ahead of what else is out there. And we also developed our own supply chain. So we're not reliant on, other large companies to use their structures. So by bringing all this in-house, by staying focused, and by having already committed so much time and investment, I think we're truly aligned to, be at the forefront of marine innovation.
So let's just dive in a bit to what the other guys are up to, because let's take Honda then. They spent how much money on bringing out a 350 horsepower engine, which, I mean, I can't imagine there are that many use cases where you need one 350 horsepower engine. But anyway, there must be a case. But they would have put in hundreds of millions of dollars into that. But we all, I suppose, those of us who believe that the climate transition is inevitable, would say that's probably a sunk cost that you're never going to get back, because regulations are going to tighten. We're going to have to move to cleaner and better systems. And you've got this electrification wedge that could grow very rapidly as people discover it's a better product. So, is there something about the incumbents that mean that they just can't shift gear, that they're committed to this kind of almost arms race of who's got the biggest badass combustion engine, really?
Yeah, I think that's really their focus right now. I think electrification has been so difficult in marine for various reasons that there's been less of a push to have to do it. The marine industry is, we talk about with catalytic converters, is definitely unregulated. So the regulations are a lot lower. And while we have seen, tens of thousands of electric-only lakes across the U.S. and even abroad, those markets are growing quickly and rapidly. But again, for a lot of these larger companies, I don't think they've seen or experienced electrification actually working in a way that could replace the combustion engines.
Sorry to interrupt, but it's a bit like people kind of not really believing you could do an electric car because they associate it with milk floats, or other small utility golf carts. And then Tesla comes along and says, no, actually, if you design it from the bottom up, you can get a better car, has all the attributes of a real car or a normal car, but it's just minus the pollution.
Exactly the same thing. And we're kind of at that tipping point where I think we're starting to show the world, and there's some other companies focused on it too, but showing that electrification is possible to make a real dent in the marine industry and offer a true alternative.
Just thinking about the US market, there is another new entrant into the space on the West Coast. ARC are developing kind of very high end, very beautiful, luxurious boats. But do you see them as competitors, or how do you view? I mean, it's a big market, so you can both sell into it. But who are your competitors?
Yeah, so I definitely see them as another company in the space. It's obviously a huge market, and there are many different ways to approach the market. And I think they're going to probably do a very good job filling a certain niche of the market. But if it's almost less about who are our competitors and who are their competitors. If you're building a fully electric boat, you're competing with the other boat companies, the other boat brands. Whereas Flux Marine is really partnering with the other boat brands. So, they might be a competitor of some of our boat partners, but I wouldn't consider them a direct competitor for us, where our boat partners are already building, hundreds or thousands of boats a year. And so we really just want to be working with all these different boat companies. And I think there's an opportunity for, collaboration. There are quite a few electric boat companies similar to ARC that have already either reached out to us, seeing if we could be their propulsion provider. And there are a number of electric propulsion or electric boat companies out there that are already now using Flux Marine systems in their boats. So for us, it's great to have more awareness around electrification. It's great to see companies filling exciting niches. But for us, we don't compete with boat companies. We partner with them.
Right. And so if that's the business, then how many partners have you got signed up, and how quickly can you ramp up the production of your facilities? And what are the near-term goals for the company?
Yeah, great questions. So I'd say we have right now 2 flagship boat partners. So those flagship partners are Scout Boats and Highfield Boats, 2 rapidly growing brands, very reputable, a number of different boat models and dealers all across the world. And then we have, call it half a dozen other partners, whether that's companies like Windtech, Begonis, Hydrofoiling. There are a couple luxury yacht tenders we're doing. There are a couple boat yards we're working with. And for us, it's, we don't want to jump into dozens and dozens of partnerships immediately. So we do want to stay focused to an extent. But it's really a model where we develop these flagship partnerships, get those off the ground, have those running, selling through their dealer networks, and then bring on new partners, rinse and repeat, rinse and repeat.
And how many? So we can hear the battery packs or whatever it is being built in the background. But what is your production rate at the moment, like per quarter? How many units are you able to produce, and where do you want to be in a year's time?
So I can't say the exact numbers we're producing right now, but it's certainly on the order of multiples per week. By next year, there will be triple digits of Flux Marine outboards out there. And as we look at 2026, there will be thousands of systems rolling off our production line.
And do you have a site in mind for the production line, or how far along is that kind of big scale up to the Tesla story, famously, it was when they found their old Fremont factory that they could repurpose that really got them to scale. Have you got a milestone in mind of where you're going to be building these?
Right here. We have a 40,000 square foot facility here in Bristol. And one of the really exciting things about focusing on the batteries and the motors and not building boats is that we do not need that large of a production plant to do this. So at our 40,000 square foot facility, we're slated to be able to build upwards of 3,000 motors a year without having to move to a larger facility. So it's very, very efficient from a manufacturing perspective.
But is 3,000 a year really going to make a dent? Like, do you have to get to 30,000, and how do you get there?
Yeah. So 3,000 it'll definitely start to make a dent because they're on the order of hundreds of systems out in the world right now that are truly, 100 to 200 horsepower electric outboards. Now, as we start to scale up and look at, 10,000, 20,000, 30,000, which is still, not the majority of the market. So it's still very reasonable numbers. At that point, there will certainly be a scale up to a larger facility. As far as where that facility is or where that facility goes, I don't think there's an exact answer for that yet, but we've certainly had interest from countries abroad. So, I definitely expect to have a facility out there. And then there are a few different options for exactly where the next building can go.
I think one of the things, I know we keep referring back to the Tesla story, but it's kind of similar, right? I feel like the big OEMs of car manufacturers could have made electric cars. In fact, GM did at one point, but they sort of chose not to. And it was really Tesla who broke the mold. And I feel that this is somewhat similar, that the big outboard manufacturers could do this, but they've been putting their energies into ever bigger outboards and not electrification. So it feels similar. But that was helped along by some government credits, right? There was an artificial market in electric vehicles created by policy. And I guess the question is, has anything come through yet in terms of the IRA? We just did an episode with Ethan Zindler of the Treasury, looking at all the tax credits that have come in for a whole host of end products and upstream investments into manufacturing. Is there anything in there for marine propulsion at the moment, or can you imagine that could come?
It definitely could come. I'd say it's still early days. We've started to see some money and some funding around port infrastructure, electrification of ports, but it's truly early days. I think one of the reasons for that too is, you need lobbyists, you need a lot of, advocacy in the space. And we are seeing more and more of that. There's a group, IEMA, the International Electric Marine Association, and they're really starting to push on the policy side. But 5 years ago, there were really no electric options for boats out there. And so there was no policy because there was no solution. Now that we're seeing companies like us, companies like Candela, starting to actually have products in the field in production, I think that's going to start to trigger more of the policymakers to actually implement things that will help catalyze the industry.
I wanted to just take a little bit of a zoom out at the end here to think about how in the West, I think we've talked about here very, we talked about recreation vehicles, we talked about sports vehicles, but here in the West, that may be the main use of boating. But out in the developing world or in emerging economies, boats are real lifelines. I mean, they're providing vital sources of nutrition through supporting fishing, or they're acting as they enable tourism, or they're using rivers as corridors for trade and commerce. So, in a way, I would love to see this leapfrog of what we've seen happening with electrification of, say, 2- and 3-wheeler vehicles in emerging economies. Can you imagine a kind of future scenario where we're seeing the benefits here of almost independent electricity-driven marine propulsion being benefited in the emerging economies?
Oh, absolutely. Especially as you think about those emerging economies and how challenging it is to move gasoline around and actually get gasoline to groups. We've had conversations with people who live in Fiji, for example, and the struggle to get gas in your boat. The gas is extremely expensive because of how much it takes to move it around. But as you start to think more about that distributed energy model, solar panels, microgrids, all of a sudden implementing that in conjunction with electric boats, you now have both something that can use that sustainable energy, but also store that sustainable energy, significantly reduce operating costs. And I think that's going to be, a really interesting application of the technology, and something that I will certainly expect over the next couple of years to really change the way that even developing countries look at and use electric marine technology.
Wonderful. Well, thank you, Ben. I will let you get back to the production line, and I hope the listeners haven't been too distracted by the sounds of real boats being built outside your office. I will definitely take you up on the offer next time I'm over on the East Coast of taking another trip. I personally was blown away by the speed, the quietness, as you say, the lack of fumes on the trip that we took, and I'm sure many other people will be too. So thank you so much for spending your efforts in solving this problem. All that tinkering is going to pay off, I'm sure.
It certainly will, and thank you for everything you do, and your focus on highlighting people innovating in the space, and moving along and showing everyone doing their part in this energy transition.
Fantastic. So that was Ben Sorkin, CEO and co-founder of Flux Marine. I hope you enjoyed the episode, and as usual, we'll put links in the show notes to the other episodes and issues we've mentioned. My thanks go to our producer Oscar Boyd, editor Jamie Oliver, researcher Jeannie Harrison, and to the growing number of people making this podcast possible. Join us next week for a new episode of Cleaning Up.
Cleaning Up is brought to you by the members of our new leadership circle. So that is Actis, Ecopragma Capital, EDP Portugal, Euroelectric, Gilardini Foundation, KKR, National Grid, Octopus Energy, Quadrature Climate Foundation, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform and leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues, and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com.